Hello students, today we are going to discuss about prime numbers, its properties and how we can check a number if a number is prime or not. So we are going to see a shortcut method for that. Okay, so first thing, what exactly is a prime number? Okay, so a natural number larger than unity is a prime number if it does not have any other divisor except for itself and unity. So now, what does it mean? A natural number. Now first thing, what a natural number is. Okay. So all those counting numbers are natural number. What exactly are counting numbers? So the numbers which we can count, like 1, 2, 3, 34, 36, all those things we can't count 0. Okay. So all numbers starting from 1 and till infinite. Okay, all these numbers are natural numbers. Fine. So a natural number larger than unity. So prime number can never be 1. 1 is your unity. Okay, so a natural number larger than unity. So prime number for sure will start from 2. So numbers starting from 2, 3, 4 till infinity, these possibly can be prime number. I'm not saying that all the numbers from 2 till till infinity are prime. A natural number larger than unity is a prime number if there is a condition, if it does not have any other divisor except for itself and unity. It means that all these numbers can be prime number if there is a condition that they does not have any other divisor except for itself and unity. That means this number should not be divisible by any other number other than itself. Means we know that every number is divisible by itself. 7 is divisible by 7, 12 is divisible by 12, and also every number is divisible by 1 also. Okay, so if the number does not have any other divisor except for itself and unity, then that number is a prime number. Now let's see for some examples, like 7. Okay, 7 is only divisible by 1 and 7. Okay, so 7 is a prime number. But let's take for example 12. This is divisible by 2. Okay, by 6 times. In 6 times we can divide 12 by 2. Then 3, 4, 6 and 1 and 12 as well. So 12 cannot be a prime number. Then these kind of numbers which are not prime are said to be composite numbers. Okay. So am I clear till now that prime numbers are natural numbers that are larger than unity if it does not have any other divisor except for itself and unity. So for example 7 is only divisible by 1 and 7, but 12 is divisible by all these numbers. So 12 is not a prime number, it's a composite number, and 7 is a prime number. Let's take just 2 more examples. Let's take for example 11. 11 is divisible by 1 and 11. Can you see any more factors of 11? No, there's no more factor of 11. So we can say that 11 is a prime number. Similarly, let's take 23. 23 is also divisible by 1 and 23 only. There's no more integers which can completely divide 23. So 23 is also a prime number. Now here are 2 more things we need to know. Lowest and only even prime number is 2. So 2 is the only even number, that's a prime number. Now you can check this with any example like 4. 4 is divisible by 4, 1 and 2 as well. Okay, so if you take any other even number, it will be at least divisible by 2. So other than 2, there is none of the other even numbers which are prime. So 2, apart from being the only even prime number, it is also the lowest prime number. And the lowest odd prime number is 3, because the lowest odd natural number is 1, but 1 is not considered as a prime number. Okay? Okay, now let's move on to some of the properties of prime numbers. So first property is, for any prime number p greater than 5. So we are talking about the prime numbers, but this condition, this property applies for the prime number which are either greater than 5 or at least are equal to 5, since 5 is also one of the prime number. So for any prime number p greater than or equal to 5, when divided by 6, the remainder is 1 or 5. Now let us see. Let's check. 7 when divided by 6, we can see that the quotient is 1 and the remainder is also 1. Okay. Similarly, if we will divide 11 by 6, we will obtain a quotient of 1 and a remainder of 5. So you can check this for any larger number also, that when we divide a prime number with 6, we will obtain some quotient, but the remainder will always either be 1 or it will be 5. Okay. However, if a number on being divided by 6 gives a remainder of 1 or 5, the number need not be prime. Now we just saw that if a prime number is divided by 6, the remainder is 1 or 5. But it does not mean that when we divide a number and it gives, when we divide a number by 6 and it gives a remainder of 1 or 5, the number needs to be a prime number. Now let me explain this to you with the help of example. Okay. So suppose we divided 25 by 6. Now for this, we are going to obtain a quotient of 4 and a remainder of 1. Similarly, if we will divide 35 by 6, again we are going to obtain a quotient of 5 and a remainder of 5. So for these two numbers, 25 and 35, when we are dividing these two numbers by 6, in the first case, in the case of 25, we are obtaining a remainder of 1, and in case of 35, we are obtaining a remainder of 5. Okay, but both of these numbers, 25 and 35, are not prime numbers, since we can see 25 has factors. It is divisible by 1, 5 and 25. Similarly, 35, the factors are 1, 5, 7 and 35. So these two numbers are not prime numbers, but still when divided by 6, it will give a remainder of 5 and 1. So it means that if we will divide a number by 6, it may or may not give 1 or 5 as a remainder, but this doesn't mean that the number needs to be a prime number. A number can be composed also, but when a prime number is divided by 6, the remainder needs to be 1 or 5. Okay, so moving on to the next property. So the next property is, for any prime number p which is greater than 3, p square minus 1 is divisible by 24. When it is divisible by 24, it obviously needs to be divisible by 12, 6, 4, 2. So basically, when we have a prime number p greater than 3, p squared minus 1 is divisible by 24. Okay, so let's check for this. Let's see an example. So let our value p is equal to 5. So we have p square as 25 and p square minus 1 is 24. So yes, it will be divisible. You can check this. I am just giving two examples. One, p is equal to 5 and p is equal to 7. You can check this property with the help of any larger number. So when p is 7, p square will be 49 and p square minus 1 will be 48. And again 48 is divisible by 24. Now we can also see this in a form that if we will divide square of a prime number with 24, we will always obtain a remainder of 1. Okay. So this is the second property. Okay. So let's move to the final step, final stage of our video. The shortcut process, how we can calculate if a number, how we can check if a number is prime or not. Okay. So first I'll just explain you the methods, the steps to this method, and then with the help of an example, I will explain this to you. So let our number be x. Okay. So first we need to calculate the square root of x. Like if our number is suppose 25, we need to calculate the square root. It's 5. If our number is suppose 49, so we need to calculate, okay, that square root is 7. If it is 144, then the square root is 12. So not all the number will be a perfect square. So there will be the numbers which will have square root in form of decimal. So first we need to calculate the square root, and the second step will be we need to round it to the immediate lower number z. Suppose we obtain a square root which is 12.36. So the square root we will round it to 12. Okay, so we will round it to 12. Now let's suppose the number is 12.56, but again we will round it to 12 because we need to round it to the immediate lower number z. Okay. Then the third step is we need to check the divisibility of x by all the prime numbers till z. Okay. So let's solve it, check it with the help of an example. So suppose we have our number x is 103. So what was the first step? So we need to calculate the square root. So the square root of 103 is 10.14 approximately. Okay. So the second step was we need to round it to the immediate lower number z. So our z will be 10. We will take this integral part. Now what are the prime numbers till z? So till z, the prime numbers till 10 are 2, 3, 5 and 7. Okay, now we need to check in the third step. We don't need to calculate. Now most of the students, like many of the students I've seen, when they are given a number and asked if it is prime or not, suppose the number is 103 only, what they will do is they will start dividing it with 2, 3, 4, 5, 6 till 100 or 102, and this takes a lot of time and it's useless. So what exactly we need to do is we are going to do this. Now we need to check 103 with only these numbers. So we need to check 103 if it is divisible by 2. So obviously we can divide this. We will obtain 51.5, but that's not an integral value. It's not completely divisible. We are obtaining the answer in form of decimal. Okay, so 103 is not divisible by 2. It is again not divisible by 3 as well. I hope you know the divisibility by 3, how we can check. So we will add all the values, all the digits. So 1, 0 and 3, when we will add it, it will sum up to 4, and 4 is not divisible by 3. So this is also not possible. 5, again it's not divisible by 5, and it's not divisible by 7 as well. So 103 is a prime number. Okay, so you can check any number with this method. So I hope till then you would have understood. Till then, bye.